First of all, thank you very much, Paris, for taking this interview with us today. We're very, very happy and elated to have you with us today. For the audience that's watching us right now, Paris is currently a group leader in the Max Planck Institute for Eisenforschung in Düsseldorf, if I'm not mistaken.
Düsseldorf, yeah.
And Paris is working on things relating to superalloys and titanium as well, if I'm not mistaken.
A little bit titanium, like aerospace.
Yeah. So first of all, once again, thank you very much for having us for coming to this interview. Basically,
thank you for the invitation.
We would like to start things off by asking some things about your overall experience in the field of material science, and basically how did it occur to you to select material science? I mean, I know from your original degree, which is the same I took, that the initial subject, mining and metallurgical engineering, is quite vast. So did you start your bachelor's degree thinking that you would like to go towards material science, or did you find that during the bachelor experience?
Yeah, very good question, actually. We have the same degree, and until then I had no idea about material science, even about metallurgy, so I found out about that later. So during the undergraduate studies, we had a course. So the whole degree is 5 years, just to put it in context, and then you have the first 2 years, you do a lot of mathematics and physics. And we had the first courses about maybe metallurgy and material science. And so until then, I had absolutely no idea about material science. And what fascinated me was we had a course on steels and microscopy. And then we could see actually dislocations in the microstructure, and we can actually see microstructures. So for me, it was like a new, completely new world coming up. And I think that was the moment that for me it was, I want to do material science and not, well, material science and metallurgy. So those two coming together.
Right.
Metallurgy in Greece, like at least in our degree, was a little bit about hydrometallurgy or pyrometallurgy, not like physical metallurgy.
Yes. And the most impressive thing, if I understand the subject correctly, that was a 9th semester subject or 8th semester subject, if I remember correctly.
For what you mean?
The one that got you interested in materials?
No, that was on the second year, I think, the second or third year. It was before even decided which direction we want to take.
So physical metallurgy.
Yes. So it was even before the courses specifically on the physical metallurgy. It was the general course for everyone.
Right. So that actually got you interested in material science, I guess. And moving on towards the completion of your degree, how are you selected to do a master's degree next instead of going to work or anything? What was your thought process while finishing the original degree?
So that's a bit complicated story. So I knew, I was thinking that I want to do a PhD. And our degree in Greece sometimes is not recognized, or at that time it was not recognized as a master. Mm-hmm. So I want to do a master anyway in order to be able to study, because it was not clear in my head if I would go to UK or Germany or some other countries. So I want to do a master degree, not be able to do a PhD later. And
right.
That's how I continue with that. And also I like the science, the material science, so I found it. It was not like a push for me. It was something I want to do.
Yeah, I understand. And something which actually I found very interesting, you seem to have been very invested in superalloys specifically from your master's even, and you kept that until basically now. You're still working with superalloys.
Exactly.
Why so much superalloys? What did you enjoy about superalloys?
So superalloys, we had at the university, at the undergraduate degree, we had a very small part about to be taught about superalloys. And then during my master's, I want to do an Erasmus exchange for my master thesis. And then there was a project in Aachen University in Germany that they want someone to do a master thesis project on superalloys, and this is how I started. So until then, I didn't know so much about superalloys because undergraduate didn't cover so much.
Right. Okay. Because it is interesting because you actually managed to get a PhD in superalloys as well. So that it's really rare to be able to do something in your master's and then be able to transition in the exact same field in your PhD. So did you?
I don't think so. I mean, every field, like even let's say titanium alloys, you can do different things. It doesn't mean that you just did one thing. For example, for my master's on superalloys, I did castings. So casting like 60, 80 kilos of superalloys and trying to look at the microstructure in the macro scale. My PhD was completely different. It was still on superalloys, but it was a completely different subject.
Yes, I understand now. And in general, in terms of the actual PhD experience, did you have, as one would say, the typical PhD experience, which consists of varying degrees of madness, or did you actually have a relatively smooth experience, and how did it all go, basically?
I had the very typical PhD madness, because actually I started my PhD at the University of Birmingham, and 9 months in my PhD, my supervisor comes to me and says that he's moving to University of Oxford. And I had a moment of a panic attack, but because normally if the supervisor will move, you stay where you are. But he told me, you are coming with me. And I was super happy about that because I could continue doing my PhD with him. But in fact, when I moved to Oxford, although they told us that I will continue my PhD, I had to restart everything because we had to do everything again, all the training, everything. So.
Right.
Yeah. So that was a really difficult to change labs during your PhD, and the lab in Oxford was not ready, so we had to set up the lab as well to find all the people to learn everyone there. That was a huge bump, but at the end, it went fine, I think.
Right. It sounds really interesting because I didn't actually know that when I was looking at your CV. I didn't actually see that, and so you actually managed to bounce back from that and finish. I think you actually finished on time, if I'm not mistaken. Still,
kind of time. Yeah. It depends who. So if you ask my supervisor, I finished on 4 years, but for me, the first year, it went to the bin mainly because we had to shift to the other university. So in Oxford, it was like 3 years, 3 and a couple of months. Yeah.
That's really impressive, and it's really admirable how so when you went into doing a PhD, did you have in mind that, oh, I want to be involved in research, or I want to be involved in academia, or did you just want to do research? Because that is my following question, which is why did you go down the route of a postdoc and then research, basically?
I think that's a very important question, and so I want to stay in research and in academia, but I didn't have enough information how tough it is to stay in academia. So, and I think that's the most important thing. And even now, when I get now many people asking me, can I have a PhD with you? Can I do a PhD with you? And then the first question I ask them is like, why do you want to do a PhD? I think that's the most critical question you need to ask someone, and you need also to ask yourself. You simply don't do a PhD just because you want to do a PhD. A PhD is a very hard work, so if you want to find a job in industry, I would say that maybe some cases you need to have a PhD, but in very few cases. It's not like all the cases they need someone with a PhD. So for me, that I was somehow misinformed because I was also thinking about R&D departments in industry. So that they were telling that you need to have a PhD. From what I see now, I don't think that's always true, maybe. And that depends also on the country that you want to work afterwards.
Yeah, I understand. I think that's actually an issue still. Maybe not in the UK specifically, but from where we are from, I think it is a very typical misconception that you need to do a PhD to stay in research. Otherwise, you will lose your position. It's still there.
And that's why I found your initiative to inform people about these things. They need to ask first. People doing a PhD or they have graduated, why they're doing a PhD. So I think this is a very good thing that you're doing for future students.
Right, and so I presume that the postdoc was basically the natural evolution in respect to what you wanted to do, right? After the PhD.
So for me, I was still not so I saw how difficult it was. So I found the hard way, how difficult academia was. So because only then you find out about, the limited positions and all the things you need to do and the mobility that you need to travel, not to travel, you need to move a lot, in all times. Maybe some professors that did a PhD in one specific university, they did a postdoc there, and then they became lecturer, and then, now that is simply impossible, I think, for our generation and your generation. So when I was close to finish my PhD, I actually had a job offer from the industrial partner of my PhD, and at the same time also I was looking for a postdoc, and then the position here in Max Planck. So I did a 3-month postdoc in Oxford, and then I had the Max Planck offer, and I decided I will try 1 year. Because it was a 1-year contract, I will try for 1 year and then see if I don't like the postdoc life, I would switch to industry. That was my plan, at least. Yeah, it's not always working like that, but yeah, that was my plan, because I thought I was leaning towards research, not industry.
Yes, I understand fully. And now, from the position you are right now, looking back, do you feel satisfied with the calls you've made throughout your educational and professional career up until this point, or is there something that you would have liked to have managed differently, perhaps?
I don't know, because I don't know the other parts. I cannot see it. I'm not like Doctor Strange from Marvel. That you can see all the possible outcomes. But I'm really happy. And I'm really happy that I joined Max Planck, because it's a unique place. I mean, everyone was telling me about that, and I even picked up the position without even coming here. I came after I said yes. So that was not very wise, but at the end it worked out well. Yeah.
That's absolutely wonderful to hear, because a lot of people, I think, me included, and I think a lot of our colleagues from Sheffield as well, tend to contemplate a lot on their decisions and, oh my God, have I handled this properly and stuff like that. So it's really nice to see a person who has actually excelled in their field to feel, I could have done things differently, but I'm satisfied with where I am right now, and I feel content.
Yeah, I mean, it's always difficult, and you always have you can follow route number 1 or route number 2, but you need to decide what is the best for you at the current time, and then you try to embrace that, and you do your best that you can.
That's really wonderful to hear. So since we actually got near the current time, you could say, I need to commend you on the outputs that you've been generating. I mean, I've been an avid follower of you in Twitter and LinkedIn, and I've been following your research, and I've seen you have the opportunity to be working with an atom probe, something which most people in their even professional life, and even professors themselves, may not have even had the opportunity to see an atom probe. So it's really interesting to have this opportunity. And with that, I would like to ask you, from all the work that you've done during your time in Max Planck, what would you consider to be the most influential output you've made thus far?
That's a tough question. Yeah, I think I will not forget the moment when I really it was my first time that I saw dislocations in an atom probe data set. So it was looking like a tubular feature, it was like a cylinder somehow. It was decorated, and I could see that. And I've never seen something like that. So just ran to Baptiste's office, Baptiste Cole, who is still the group leader of the Atom Probe, and I asked him, what is that? Is it a kind of artifact? And he told me, no, that's a dislocation. I was like, seriously, that's a dislocation? Yeah, that was a dislocation. And that day, that something started with the superalloys that we could see the segregation and dislocations. I mean, we knew that, but because in superalloys we haven't seen it before, like that in that detail. And then we published a paper. I think that paper, it was for me until today the best piece of work. I mean, we've done a lot of work later. But I think that it was like, we opened Pandora's box, somehow like that, it felt like that, yeah.
It must have been wonderful to be feeling that, because I know that a lot of our viewers actually may have been feeling the same for their research as well, when you discover something which you feel is truly unique. And it's really nice to see this coming from you. And even at that point, right? Even after you finish your postdoc, you're still discovering things, with the Atom Probe and stuff. So it's really an interesting aspect of science that just never seems to go away, right?
Yeah.
So
that was actually my first year here in Max Planck.
In the first year, that's really nice.
And then so we saw that and we're really excited. And at the time, we didn't know what it meant, and we're trying to put the pieces together. So for me, that was, and still, actually, I have a picture of that. Normally, when the Atom Probe data, we see a heat map where the ions hit, on a map. And then the way the dislocations were, they were like, they were forming like a sad smiley. And actually, these were the dislocations, but actually that sad smiley made me very happy later. And it was a very ironic sad day, because I saw that and I thought, what is that?
That must have been a nice day to remember and look back on. So I take it that perhaps this is probably also the project which you also enjoyed the most. Is that correct? Or is there something else more? Oh, right.
I think that was a very nice project. And also now recently we do a lot of work with additive and superalloys again. That's also something very fascinating. We see things in a different way now, and I think it's also very fascinating work.
Right. In terms of, since we touched on that, I haven't planned on asking this right now, but you mentioned additive manufacturing, and in general, from your experience working with components that have been perhaps additively manufactured, a question that is posed a lot actually, and I don't know if it's a good question to ask or not in general, is, do you consider additively manufactured parts to be able to overtake certain parts of traditional casting completely?
I'm not an expert in additive, okay? What I'm trying to do is just try to understand the segregation, for example, grain boundaries in superalloys, but I'm not an expert about if that can happen. I think at least for the aerospace part, some manufacturers, they claim that they have produced by additive manufacturing some components, not for the engines. So I don't know. For the engines, I think it will take a lot of time. If that will happen at some point, because of the high risk, if you have a blade failing or something like that, these are very safety critical components. So it will take, I think, a lot of time for the community to actually trust additive, and for additive also to achieve the standards that, for example, castings they have right now.
Right.
So there need to be a common mutual trust there in order for additive to
So in respect to that, one opinion that has been vocalized a few times is that we shouldn't actually be comparing additive to traditionally manufactured and make the two techniques compete with each other, rather than start to think about where each technique can complement another in terms of specific component manufacturing. So in cases where you have very, very complex geometries, you should be going with additive. And in cases where you would have something that can be mass produced very simply and is a simple cast, you should just use casting. Do you embrace that train of thought still from what you have studied up until this point, or do you think that we should think about replacing some things in the future?
I agree, and particularly, for example, the alloy development. So at least I will speak in the case of the superalloys, the little I know. So people are trying to, so you had the compositions that you were using as cast compositions, and people are trying to produce by additive the same compositions. And that's not happening. They cannot do that. And they're trying to find the parameters, and they have cracks and other problems. So I think in that case, you need to develop new alloys that they fit this particular technique. You know, over the years, they have developed alloys for castings or for powder metallurgy, and they, made them particularly for these processes. So now you have a completely new process. You have different conditions. You cannot use the same alloy that you use in casting to use them in additive manufacturing.
Yeah.
And from the work I've done, I've seen that a lot. And I believe that, for example, they need to develop new alloy compositions that they fit this process.
Right. So another thing which may be interesting to be looking at in general is to be making single crystalline superalloys through additive manufacturing. And there has been a lot of work happening in that area in general. Do you think that this could be a viable way to produce such components for additive, or do you consider the traditional methodology, which is extremely hard to pull off correctly, but still it's been standardized to the point to be better?
Again, for additive, I'm working with polycrystalline alloys, but I've seen some examples from some people working on the field, even here in Germany, in Erlangen, that they actually managed to produce bars, single crystal bars of superalloys. Now, if they can do it also as a component, I don't know.
I just hear your opinion on the matter. So.
I don't know. Even from casting, so even from my PhD, I was casting bars, cylindrical bars, and then everything was fine. But then we had to do a real casting of the real component. In that case, everything was completely different.
Right.
So by going from a bar to go to the component, it could be a completely different story.
Right.
That's from my limited experience in that part. I don't know. We'll see.
And now moving back to superalloys, alloy design in general. We have seen a lot of alloys being extremely famous, Haynes 282, Inconel 718, that we're all being taught in the university, CMSX4 perhaps as well. And we hear so many categories of alloys. So moving forward from your experience, do you think that there are any upcoming superalloys that we should be keeping an eye out for?
This is a tricky question because sometimes you cannot reveal. It's difficult to say things. I think I don't think that we will see huge changes because superalloy has been around for 40 years. But maybe minor modifications can improve things a lot that in case that we didn't know before. So it could be the same alloy, but with different modifications, some minor modifications, like more accurate modifications in the chemistry that can improve things. Because that's what everyone's working on superalloys, trying to improve the performance of the alloys in order to increase the operational temperature of the aero engines.
Right.
But there are a few things that they might come in the next few years, but still I think these are on the making. I think manufacturers are always working on that.
Yeah, I understand. So moving back to the Max Planck experience, I would like to ask two questions for that one, and my section will be completed. So the first one is, how does it feel to work in one of the most prestigious research environments in Europe, if not the entire world, every day. So what's a day-by-day basis? How is life in Max Planck? And the second issue is, do you remember anything particularly interesting or funny, a funny story perhaps about your time there or something? So these are my two questions.
So about the first question, I think we need, people are saying, Max Planck or other places like, they must be doing, they are doing great, but that they are a bit scared about that. But that's how I was feeling before I started working here. But I think everyone here is quite relaxed. What I really like here is that we don't have what someone would call a diva, a diva professor or something like that, if I'm allowed to say that. So everyone is working together. So even the directors, they will always listen. They will talk to the master students, for example, or to the other people. It's not like they don't respect them or something like that. But I have seen in other places. So I think that's the beauty and what makes Max Planck unique. That everyone works together here. We're like a big family. We don't have like each group is not separated by the other group. And I think that makes everyday life much easier.
Yeah. So before you proceed on the next question, now you've given me a nice opportunity to throw something here for the people. So if someone wanted to work in Max Planck, they're just finishing with their master's degree or the bachelor's, what would you, and they are interested, they are absolutely fixated on, I want to be able to work in this environment at some point in my life, what would you advise them to do?
You mean how they can contact us, or?
I mean, steps in their career that can help them excel to a point where they may be, able to compete for a position in Max Planck, basically.
That depends on the level. If you have already finished your PhD and you're looking for a postdoc, or it depends on each individual level that we're talking about. Like we can talk for like an hour about that. I think if you want to contact at least someone, I would say first of all you need to really prepare your CV as good as possible. Bring out your strengths and keep in mind. No one is perfect. In our day, they ask for every position. They like publications. Like you finish your master's degrees now with publications. It's too much. It's simply too much. It's too much stress on the students and the PhDs and the postdocs, and grants, and you have awards, and you have everything. If I had everything, I would be a professor already from my 18 years old. So I would say just prepare your CV as good as you can and contact the people, be polite to the people, and and you never know. I would say don't wait to see an open position. Sometimes, we have people, and we don't have enough CVs coming some days in, or not the right time, and then we need to find someone who was already working here, for example, to continue a project. Right. So if you're really interested about the topic, just send an email to a group leader or someone else working there and ask them, do you have something on that? So.
Right, that is really interesting.
And not just for Max Planck, I think this is how it works everywhere somehow.
Oh, right, okay. That's really interesting, because I feel a lot of people would be looking to transition into such environments in the future, myself included, by the way, but never mind. So to close my section, one funny story for Max Planck. One funny thing.
Funny thing. That's difficult. Not because we don't do anything funny, but now to come to.
Or anything interesting, or anything that impresses you. Anything like that.
I think something that impressed me is sometimes we, at least before the Corona time, so in Max Planck we have 4 departments, and once a month or every 2 months we have interdepartmental meetings. where the directors of each department are there. We have a seminar room and we sit down and discuss. And sometimes they really argue a lot. And then it's quite interesting to see that, that even in that level, they, of course you will argue also, but they argue so much, and then you think that they are fighting, but actually they are really passionate about that. And at the end of the day, then after maybe 1 or 2 hours of fighting, then they just come with a proposal. Because say, that's a very exciting project, we need to do that, and let's come up with a proposal. So that's one of the very interesting things, that the first time I experienced that, I was really shocked. I thought that if you're a PhD student or a master's student, you see that, you think they are fighting, but actually they are not fighting. That's their passion.
It's really interesting to see it from that perspective, actually, because most of us do not have the opportunity to experience these people like that, but listening to this whole experience.
And possibly, I wouldn't see that, for example, in the UK. I wouldn't see it like that.
Do you think it's Germany exclusive?
No, I don't think so. Maybe just the style of how the Max Planck works, this Max Planck here. But I haven't seen that in Oxford, for example.
So if anyone from our viewers wants to set up a research organization, perhaps they should consider having every once per month a boxing match between directors.
You need to be passionate in that job. I think like in every other job, if you're not passionate, maybe
Yeah, that's absolutely true. So that concludes my section of the interview. Tongyu will take it from here.
Thanks, Paul. Okay, so my next question is that we've all seen that you've done a great job in academia area, and you are a great researcher. So we are wondering whether you are considering to stay in research for a long time, or you are considering to move into industry or somewhere else. Just want to hear your plan, if you can tell us.
Yeah. So as I said earlier, after my PhD, the first year, I thought I want to try the postdoc experience, at least to have this experience to see if I like it or not. And then every year I say, okay, one more year. So far I'm in academia, and that's my plan. So I'm working towards that. But you never know. You never know how things go. Academia is really tough in terms of available permanent positions. And if in the next couple of years I cannot secure a position, then I will start thinking also about industry.
Cool.
But right now I don't have a specific plan. Yeah, my plan is to stay in academia for now.
Yeah, so I think it's rather safe to say that you are happy to stay in academia field, isn't it?
I like research. I'm not happy with academia.
Okay, I'm sorry.
This is,
It's
a bit complicated, but academia has many problems. I think like every other sector. But we're trying to deal with some of these problems, and we're trying to make the academic world a bit better if we can.
Okay, we certainly look forward to more research work, great research jobs from you, right? And since you found a proper position for yourself, can you share a bit about how a PhD graduate will make their own way to a proper position in research field?
Yeah, I think at the PhD level is quite important, without putting any stress on that, to have publications. I was lucky in the case with my supervisor, because he was pushing really hard about that. But I know in some other cases, for example, that you don't have people graduating without publications. I think it's still fine, but I think at some point you need to try to think ahead that the work you are doing, you need to be able to publish that at some point. I think that's quite important, because the first few years you need to have publications. And then moving towards a postdoc, I think what is quite critical nowadays is to become independent. And again, this is a bit different from country to country. If I had stayed in the UK, I think most likely I would have to collaborate with my supervisor, continue working with my supervisor somehow, even if I was in different university. But in Germany, this is the opposite. I need to show that I'm independent from my supervisor, that I do. It doesn't matter that I still work on superalloys, and he's a superalloys world expert, as long, for example, as I don't collaborate with him. So that's also something very critical. I think those two things for the beginning. I think papers, nowadays, papers are important.
So, if I may interrupt, a question which PhD students do face relatively often is publish three papers in 3 mediocre journals, or keep all that material in one paper and try to submit in the best possible journal. What would you advise these students?
I don't think this is the same thing. For example, as people they arguing about the H index factor that they try to evaluate people. It's about the quality or it's about the quantity. I think even I say not a very good journal, but maybe your work is really good. So I think nowadays the right people, they will not check just the science, for example. Even if you, let's say you publish in Nature, okay, let's say that you have, if that's what you meant, you publish in Nature, maybe the quality of your work is not that good, and maybe you publish 3 other publications and you have a very excellent work. So I think also many universities, especially in the UK, they sign this agreement that they will not judge you just based on the quality, but just based on the name of the journal where your publications are. This is, I think, quite important. So I think for every paper, you need to try to do your best. If it's one Nature paper, yes. Some people they think, yeah, we'll have one Nature paper is better than 3 papers. But not everyone sees that way. So I can't say what is right or wrong. And that depends also on the countries you're applying for. For specific countries, I know, for example, the PhD students or the postdocs, in order to get for an assistant professor position, they need to have at least one Nature paper as first author. So this is also very cultural, which I don't think that's happening in the UK. I don't think if someone will apply to the UK, they will ask something about that.
Okay. Thank you.
Yeah. Since you've mentioned a lot about different situations in different countries, can you share a bit with us that anything you like about each nation you've mentioned or you've stayed?
What do you mean about?
You said things will depend on different countries. So can you talk about what things you like about each countries you've stayed or you've worked in?
I think in Germany, I don't know much about Germany because we have a very special situation here in Max Planck. So because we're being evaluated, so we always need to somehow try to go to these fancy journals, as many people call them. I tried that and I didn't manage to succeed. And then, but I submitted a paper in Nature Science, and then it never went through. And then I sent it to Scriptamat, and then it went through. And it's very highly cited paper. It doesn't matter that because it's in Scripta, for example, it was not cited. But we have to try here. But in the UK, for example, I've seen that as I said, that the universities, they have signed this agreement that they will not judge you based on the name of the journal as different countries. And I know from a former colleague that she had to have at least 8 papers as first author before she can go back to her country. And she was doing a really good job. So even if she might, let's say, if she had 20 papers as co-author, they will not consider her for a position.
Okay.
Cool. And this was the bad things about academia, for example.
Yeah. All right. So apart from the publications like the quantity and quality you've mentioned, what aspect of a typical PhD graduate would you value the most for like professional advancement or success?
I think if you want to follow a topic, you really need to try to understand as better as you can the fundamental aspects of your topic. Of course, it's always difficult, and as you grow, you learn more and more. But at least, for example, after graduating with a PhD, you need to know at least the basics in your field, in this little area that you studied. I think that's quite important. Then general knowledge, for example, of different materials, to have an overview if you can. I think also if you can, I'm not saying to work on many different projects, but even if you just go to seminars, educate yourself on different aspects. We do the same here. For example, in Max Planck, we might have seminars on aluminum, titanium, zirconium, different alloys, different methods, different perspectives. And I think that's, as a PhD student, that's good because you broaden your knowledge. And some things that maybe one person is doing in their material, maybe is actually applicable in your material. So these things, and then you learn in the process. Later, you need to do also other things depending on what you want to do later. Supervision, for example, is maybe important if you can do that, and a bit of teaching. It's quite difficult for us to do teaching here because we're not a university, we're a research institute. But if you have the opportunity to teach, even if you are in charge of a lab, I think it's quite fascinating, because then you really need to have the knowledge of, the students will come to you and ask you very fundamental questions, very simple questions, and you really need to know well your subject. So I think, and that makes you better, I think.
Yeah. Okay. So here's my last question. I want to end this interview in a happy mood. So, is there any interesting you are looking forward for the next maybe 5 or 10 years in the field of material science or superalloy, anything like that?
I think what is really interesting right now, it's about hydrogen. How we can use hydrogen, how we can produce hydrogen. I think this will be quite interesting to see in the next even more than 10 years coming. I think it's coming right now very fast. Even for the superalloys and for everything. I think that will be very interesting to see. Hydrogen is very tricky element. It's small, diffuses fast, and we cannot always see it. And to see, we can see what it does, for example, in materials like superalloys or steels. About all of about this hydrogen embrittlement. But to really understand the mechanism is quite difficult. It's quite challenging. I think that will be one of the things in the future, and also to produce hydrogen in a sustainable way. But I think it's quite exciting. At the same time, it's quite exciting. It's very challenging, but also quite exciting. It can open many new avenues for the future.
So on the whole hydrogen thing, something really interesting is to see the synergy between experimental and modeling. Like I don't know if you've heard, but a lot of people are doing density functional theory simulations on how hydrogen would operate in such environments, and then they try to verify these things that they see experimentally. Something which I do not know, however, is how can you see hydrogen, because from obviously SEM, TM not really do the trick here. I think, can you see hydrogen with the atom probe?
Yes. So there is a whole. So Baptiste, who is again the group leader here of the atom probe group, the last 4 years, they're developing like a kind of protocol in order to be able to detect hydrogen in materials. So at the beginning they had to develop the infrastructure to do that, and now they're being able to do experiments on that. And from what I know, also, which is very exciting for UK, is that the Imperial College they got a very big grant, so they will have a new atom probe and cryo capabilities. So for hydrogen, for example, and other things. So I think that's also going to be very exciting for the UK as well, because you need to have this cryo transfer. For example, you need to prepare your samples under cryogenic conditions in order to trap hydrogen inside the material, to not let it go, and then to do all these steps. I don't want to go into details now, but yeah, so this is what we do here in Max Planck right now, and I think soon you will be able to do it also in the UK. I think it's quite exciting.
It definitely
It will be very exciting in the next few years. See new things coming up almost every day.
Right, thank you.
Yeah, thank you very much.
You're welcome.
So we have indeed reached the end of our discussion today. I hope you've had a pleasant time. I'm certain that our video editors will have a lot of work to do because we need to shorten this entire thing to 15 to 20 minutes. But we've gone over some very, very interesting points, I think, that are insightful for anyone interested in doing a career either in academia or in research such as yourself. And I think we've gone over some very interesting points for people who want to do that. We also had the opportunity to talk a little bit about superalloys, a little bit about additive manufacturing, future outlooks in general. And I would like to thank you for giving us this very informative interview. And I'm wishing to keep seeing your amazing work over in LinkedIn and Twitter as much as possible. And thank you very much.
Thank you.
Thank you for the invitation. And I wish I helped you. And you know, I'm always happy if someone has questions or something like that, or you want to talk again. I think it's quite important to, before you start the PhD, for example, or things like that, you need to speak with different people, and later to find good mentors. Good mentors can, I didn't mention that earlier, but a good mentor can open many doors.
Right.
So I think a good mentor is the most important thing.
Right.
One can find, yeah.
So would you be happy for us, for example, to put a means of contacting you in the video description, for example, or in the relevant post or anything?
Yeah, if I can help with something, yeah. It would
So to put this in a video perspective as well, anyone who'd like to contact Paris for anything relating to education, his experiences, or just seeking advice in general, we will be providing you now with contact details for Paris, where you can ask him and answer most, if not all, of your questions. And thank you very much for giving us this opportunity. All right, I think we're pretty much done. Yeah. So you can stop recording now. Thank you. Honestly, thank you very much. It was really, really easy to get this going. Honestly, you're very phenomenal in terms of interviewing.
No,
you made it easy.
At some point, I was frozen. I didn't know what to say, but yeah. I don't know. I don't want to have like 1,000 emails coming in every day, you know, asking about that. But yeah, you can maybe add it just on the description if someone will contact you, and they want to ask something. Maybe then that's the best way to do it. Maybe if they contact
or
you,
in the comments, perhaps. Actually.
Yeah.
What? I didn't hear that.
Leave questions in the comments.
We'll check the comments. Yeah, timely and
It will be
them.
on YouTube anyway, so they can just type stuff there and, you know.
Okay.
So yeah, with all that, we're nearing the end of the meeting. Thank you very much for giving us this opportunity.